Hi, I'm Lithia. My project is called BandUp, which is an AI-powered MUET practice web application. This project is supervised by Dr. Anusha. First, we need to understand what is MUET. MUET stands for Malaysian University English Test. It is a proficiency test that measures your ability to listen, read, write, and speak in English. Students receive a band from Band 1 up to Band 5+. MUET is required for degree studies in public universities. It is also recognized and accepted by universities in both Malaysia and Singapore. Let me share some background on why MUET matters. According to the Google Form survey I conducted, 72% of respondents said MUET is very important for their future. This is especially true for high-demand programs like law, engineering, and medicine, which often require higher bands. A matriculation student realized MUET is a must exam and felt stressed since they need to achieve higher bands to continue their studies. MUET is held 3 times a year. In Session 3 of 2023 alone, over 71,000 candidates sat for the test. With so many students depending on MUET, what's stopping them from preparing well? First, static documents. The official MUET portal only offers PDFs, no interactive practice or instant feedback. Second, general English tools. They use IELTS standards from Band 1 to 9, but MUET uses Band 1 to 5+, so students get irrelevant feedback. Third, lack of an admin analytics dashboard. Without data, admin rely on guesswork to improve the platform. To address these problems, BandUp has 3 main objectives. First, to develop an interactive MUET practice web application which allows students to answer past year questions with MCQ for listening and reading, text input for writing, and audio recording with speech-to-text for speaking. Second, to develop a MUET-specific feedback system using RAG architecture that vectorizes band descriptors through an embedding model with KNN for semantic retrieval and an LLM for feedback generation. Third, to develop an admin analytics dashboard that uses K-means clustering to group students and display insights. BandUp has 4 main components. First, the listening component. Students answer 30 MCQs across 5 parts within 50 minutes. Second, the reading component. 40 MCQs across 7 parts within 75 minutes. Third, the writing component. Students type 1 guided email or letter within 25 minutes. Fourth, the speaking component. Students are given 2 minutes to prepare, followed by 2 minutes to present. BandUp has 4 core modules. Let's look at how each module works. First, the user management module. This includes registration and login. Only students need to register while admin account credentials will be provided. There is also an edit profile feature for both students and admins. Next, the interactive practice module. This module involves students answering past year questions. First, students select a component, then they choose a practice set from the past year question bank. The timer gets started and students submit their answer once done. Listening, reading, and writing are text-based, so they are stored directly in the database, while speaking audio is sent to Grok Whisper API for speech-to-text conversion before storage. The third module is the MUET-specific feedback module. This is the intelligent part of BandUp. Take note that my system only gives an estimated band for each component separately. There is no overall aggregated band. The first feature of this module is vector embeddings. Both the MUET band descriptors, which are taken from the official MUET document, and the student answer are vectorized. They are converted from text to vectors using the Gemini embedding model. Then, the RAG pipeline follows 3 steps. The first step is KNN semantic retrieval with K equals to 3. It uses cosine similarity to find the top 3 most relevant band descriptors. The second step is augment, where these 3 descriptors are added to the prompt for band estimation. The third step is generation, where the LLM produces the estimated band and feedback. Fourth module is the Admin Analytics Dashboard module. This module allows admin to view student clusters. The main feature of this module is K-means student clustering. This algorithm uses Euclidean distance to group students into 4 clusters by their recent bands. The first cluster is good understanding skills. These are students with high listening and reading but low writing and speaking. The second cluster is good expressive skills, where students have high writing and speaking but low listening and reading. The third cluster is balanced performer, which includes students with similar bands across all components. The fourth cluster is foundation needed. These are students with low bands in all 4 components. Next, admins can view analytics and visualizations of these clusters. Finally, admins can also manage past year questions through this dashboard. BandUp uses a 3-tier architecture: presentation layer for user interfaces, application layer for AI logic, and data layer for storage. For the front end, BandUp uses React.js with Tailwind CSS and ShadCN UI. For the back end, BandUp uses Fast API and Python. This includes the Gemini embedding model, the Gemini LLM, Kisnen, K-means and LangChain to connect the RAG pipeline. It also uses the Grok Whisper API for speech-to-text conversion. The data layer uses Supabase Postgres with the PG vector extension for vector storage. Moving on to the system demonstration, so here is the BandUp landing page. On the sign up page, students need to enter their full name, email and password to register. Now let me just log in with a demo account. Once logged in, students land on their dashboard. It shows the progress cards, practice history and a calendar to track the activity. Now let me show you the reading component. There will be a list of practice sets to choose from, so once chosen, the timer starts immediately. You will see passages across 7 parts, followed by 40 multiple choice questions. Now let me just answer a few questions. Once done, click the submit button. Then a loading screen appears showing the AI is processing. Finally, as you can see, the system provides the estimated band and the feedback. The feedback includes your band results explanation, a part-by-part breakdown of what you did well, where to focus for each part, how to improve, and the next target. At the end, there is also an answer breakdown where green shows correct answer and red shows incorrect answer. Now let's move on to the listening component. The listening component is very similar to reading. Instead of reading passages, you will listen to audio clips across 5 parts, followed by 30 multiple choice questions. So for example, let me just play the part 2 audio.
Part 2. Listen to a talk by Madam Sharifah, a career guidance teacher.
The submission and feedback is same as the reading component, so let's just move on to the writing component. As for the writing component, students have to first choose a practice set and then the instructions will be displayed along with the email and the notes to be answered. Below is the text area where students have to type in their answer. Now I will just paste a sample answer. As you can see, it will show green if the word count is more than 100 words and it will show red if the word count is less than 100 words. After submitting, again the AI will give an estimated band and feedback. So in writing component, the feedback on what you did well and where to focus is different from listening and reading component because now it talks about task fulfillment, like whether if you have addressed all the notes, language, grammar and more. There is also a suggested sample answer and submitted answer displayed. Now let's move on to the speaking component. As for the speaking component, students have to choose a practice set. Then there will be a list of topics to choose from. Once a topic is chosen, there will be 4 candidates with different tasks. The user needs to choose only one candidate since it's an individual presentation. Once the candidate is selected, the preparation timer starts. I've set it to 30 seconds instead of 2 minutes just for the demo purpose. Same for the presentation timer. For your information, the preparation feature lets you to write notes and refer to them during the presentation. Then the page will ask for audio permission. Now I'll just start the presentation. Technology helps with housework in many ways. First, washing machine wash our clothes automatically. They save us hours of hand washing and can handle large loads at once. Second, robot vacuums clean the floor by themselves. They can reach under furniture and can be scheduled to run every day. Third, dishwashers clean our dishes without any manual scrubbing. As for the speaking component, the AI detects the filler words, and the feedback on what you did well and where to focus also differs from the other components as shown. It also gives a suggested answer and shows the submitted transcript, just like the writing component. So that's all for the speaking component. Let me show you the analytics page. This feature gives an overview of the students' performance across all components. In here, students can see their recent bands, progress over time, and total number of attempts. Next is the edit profile feature, where students can update their full name and email address. Now I will log out and log in as admin. This is the admin dashboard. It shows the K-means clustering cards. Let's see the manage question feature. Place all the 4 components. Within each component, admin can create, edit or delete a particular practice set. For example, creating a new set for reading component. It requires filling out all the necessary fields. It will show an error if the admin didn't properly fill it out. Let me show you a successful edit of a practice set. As you can see, there is a message saying successfully edited. And here's the delete functionality. Same goes to all the other components. As for the K-means clustering analytics feature, it shows the total number of students in each cluster, a detailed K-means graph, and also students clustering information. Admin also have an edit profile feature to update their full name and email address. BandUp also offers clear benefits to both students and admin. For students, BandUp helps improve all 4 MUET skills. They get an estimated band instantly after each practice. They also learn faster with immediate AI feedback. For admin, BandUp allows them to see clear performance patterns through clusters, identify which skills need more attention, and manage questions strategically. BandUp's entrepreneurship opportunity is supported by real market data. As we can see from the chart here, MUET candidates keep increasing every year. Malaysia also has 408 edtech companies with $8.87 million in total funding. 31 of these companies are funded. This tells us that investors see value in educational software. These statistics prove that our target clients exist and are growing. So who are our target clients? There are 4 groups. First, Majlis Peperiksaan Malaysia, in short MPM. They are the ones who directly manage all MUET candidates. This is a B2B subscription opportunity. Second, individual MUET candidates. There are over 100,000 candidates every year. This is our B2C subscription market. Third, edtech startups. They usually have large student user bases and high demand for educational software. This is another B2B opportunity. Fourth, language and tuition centers. They need digital practice tools for their students, which is also B2B. This brings us to BandUp's revenue model. BandUp follows a hybrid model. The free tier offers 3 practice sets per month with basic feedback and no band estimation. The pro tier is for B2C subscriptions. It includes unlimited practice sets, full AI feedback with estimated band 1 to 5 plus, and progress tracking charts. The institutional tier is for B2B subscriptions. It includes all pro features for up to 100 students, an admin dashboard, and past year question management. So that is BandUp, a platform built to solve real problems and help students succeed. That is all from me, thank you.